Well, I'd like us to have a look at double angles. I'm going to start with the sine. The sine of A minus B is equal to sine of A multiplied by the cos of B minus the sine of B and the cos of A. This way A, and this way B there. This will be there. Now here is not the sine of B, but the sine of A. Here is not the sine of A, but the sine of B. And on this one here, I have the cos of B. Here is the cos of B. I hope you realize that here I'm swapping the angles. Angle A here, angle B there, angle B on the cos, angle A on the sine. Now that's what you have. Let's look at the sine. The sine of A plus D will be the sine of A multiplied by the cos of D plus the sine of D and the cos of A. Now let's see what happens if I say on this one here, A and D are equal. Therefore, I'll have the sine of A plus, when we say A and D are equal, I can also write A here. A there. This is the same as the sine of 2A. Now, this is called a double angle. If we go to our distribution mechanism here, we'll have the sine of A multiplied by the cos of A plus the sine of A the cos of A. Now, if you look carefully, this is the same as that. So this is twice the sine of A multiplied by the cos of A. Now we say the sine of twice A is equal to 2 times the sine of A, the cos of A. Now let's have a look at the, we said this is a double angle, and the top one will be compound angle. Compound angle. Now let's see what happens if I have a cos. What will be the cos? The cos of A minus a B will be the cos of A, the cos of B, plus the sine of A, the cos of A. That's how it's supposed to be. Now be careful as to the sign here is a minus, but the sign here is positive. Now let's see what happens if A was equal to B. Or let's say if I have the cos of A plus D, this will be the cos of A, the cos of D, minus the sine of A, and the sine of D. So on the top one is a mistake here. This is supposed to be, the sine. It's supposed to be the sine of A. Now, realize that this is a cos multiplied by a cos. When you had a sine, it was a sine multiplied by a cos. Here, a sine multiplied by a cos. Here is a cos and a cos, sine and a sine. Realize that there is separate development here. Whites one side, blacks one side. And this cos ratio is funny. It had here a positive, and a minus here, with a minus here, a positive, and that apartheid as well. Now let's see if I had the cos of 2D, this will be the cos of D multiplied by the cos of D minus the sine of D multiplied by the sine of D. And that will be cos squared D minus sine squared D. So we have a double angle here, and you have the outcome there. Let's see what happens. We said cos 2D is equal to cos squared D minus sine squared D. This is a double angle which is expressed in terms of two ratios, two trig ratios, a sine and a cos. We can as well express that in terms of a single ratio, either sine or cos. Choice is yours. We know that there is a relationship between sine squared and cos squared. And what we know is that from Pythagorean identity, the sine squared d plus the cos squared d is equal to 1, making the sine squared d equal to 1 minus the cos squared d, or equally well, cos squared d can be expressed in terms of sine squared d, transposing one ratio there. So I'm going to write cos in terms of a sine, so that 1 minus sine squared d minus sine squared d, and that will give you 1 minus 2 sine squared d now. Let's rewrite the same expression differently in terms of another trig ratio. We have cos squared d, which is equal to cos squared d minus sine squared d. Now, we are going to change the sine squared in terms of the cos and writing. This remains cos squared d minus the sine squared d is equal to 1 minus cos squared d. That will be removing the bracket. Now, like terms, cos squared and the cos squared here. It was twice cos squared d minus 1. I hope you appreciate that cos squared d comes up in 3 different ways. In terms of two ratios, it's cos squared d minus sine squared d. In terms of sine only, a single trig ratio, it's 1 minus 2 sine squared d. In terms of a cos, it's 2 cos squared minus 1. So it depends on what a problem or identity looks like and what can benefit you in terms of expressing a double angle of a cos as it appears in all those 3 forms. Here is single ratio here in terms of sine, in terms of cos, in terms of 2 ratios there. That's what you have. Now, let's look at how this can be applied. If we have the sine of 15 degrees, if we have to find for the sine of 15 degrees without a calculator, this can be written as the sine of 45 degrees minus 30 degrees, and that will be the sine from here on this line here of our compound. That will be the sine of 45 multiplied by the cos of 30 minus the sine of 30, the cos of 45. That gives you the sine of 45. You know, it's root 2 over 2. And the cos of 30 is root 3 over 2. The sine of 30 is a half, and root 2 over 2. 2 times 2 is a 4. Root 2 times root 3, which gives us root 6. So common denominator 4 into root 6 minus root 2. So let's have a look at another one. If you have to calculate for the cos of 75 degrees, that is the cos of 45 plus 30. That will be the cos of 45 times the cos of 30, separate development here. Change the sign into the sine of 45 and the sine of 30. That will equal to root 2 over 2 from special angles. And that will be root 3 over 2. Root 2 over 2 times a half. This is 4 over root 2 root 3 minus 4 over 2. The root of 2, so common denominator is root 2 times root 3 over root 2. Root 2 can be outside there. Root 3 minus 1 all over 4. Hope you got that. Now here we are required to prove identity. Prove the identity. It says the sine of 45 degrees plus x multiplied by the sine of 45 degrees minus x is equal to 1/2 the cos of 2x. Now, in this kind of identity, you can see that the left-hand side is a bit complicated as compared to the right-hand side. So we will start to work on the left-hand side in our endeavor to make it look like the right-hand side. Now, on the left-hand side, we will have the sine of 45, the cos of x, plus the sine of x, the cos of 45, is this portion here, distributing it. And then we multiply here the sine of 45, the cos of x, minus the sine of x, the cos of 45. Now let's see what happens here. Now I realize that I have the difference of two squares. Look at this. If I have a squared minus b squared, this is a minus b into the same a and b. What's defined is the plus here. Now this is what I realize. This is what I realize here. So it's like I'll have sine squared 45 cos squared x. Where do I get that? If I square a here, my a is sine 45 and the cos of x. If I square it, it becomes sine 45, the cos of x, sine 45 squared, and that will be cos squared x. That's what I have here. Minus the square of that is sine squared x, cos squared 45 degrees. Now, let's see what happens here. This is root 2/2 squared multiplied by cos squared x minus sine squared x. And then this is root 2/2 squared. Now it's clear to the eye that this is equal to that, which you know that should equal to that. Now that becomes 2/4, which is a half, of course, into cos squared x minus sine squared of x. This 2 here goes once, 2 here 2 times cos squared x minus sine squared x. Now, what is cos squared x minus sine squared x? If you go back here, cos squared x minus sine squared x is the same as the cos 2x. So that will become 1 over 2 into cos 2x, which is equal to 1 over 2 the cos of 2x. And this is equal to what you see on the right hand side. So you have successfully managed to prove that the left hand side is equal to the right hand side. I think that will be enough for this, unless we meet in this in the tutorials on compound and double angles. That will be enough for now. Goodbye and thanks for watching.